Between procrastination and precrastination lies that sweet spot of extreme creativity. We've been molded by time to reach this plateau after a long hike of ups and downs in our creative journey. While we are boxed in today in our homes, it's time to unbox the thoughts and concepts and ideas from some of the greatest minds in our field.
Dr. Architect Roshni Udyavaryavuda is a practicing architect and academician whose core competency lies in energy efficient and environmental design of buildings. Roshni has a PhD in resource management and is a qualified master trainer and empaneled expert on the Energy Conservation Building Code of India, awarded by the Bureau of Energy Efficiency BEE. She is Director, Roshni Devar and Associates, Mumbai, and Advisor, Environment and Sustainability, Science and Technology Park, Pune. Roshni is currently Principal Investigator for the Department of Science and Technology, Government of India's research project on energy efficient opaque wall assembly. She has more than 20 years of academic and professional experience and has traveled widely on professional assignments to more than 20 countries. Let's hear more from Roshni herself.
Good evening, fellow architects, colleagues, friends, and students. I hope everyone is home safe and healthy. And I'm sure that this crisis will be over very soon and we can be back in business. Um, but I think this crisis of COVID-19 has also allowed us time to think and reflect on our practices, the way we build our built environment, and the surrounding environment. How have we dealt with them? So, Ecospaces, this is a design approach aimed at enhancing the quality of life of the users of a space. It involves optimization of the given resources. It includes climate responsive architecture, resource efficient approach, and basically reducing your ecological and carbon footprint, and at the same time ensuring thermal and visual comfort, optimum indoor environment, reduction in outdoor pollution and noise, as well as making your spaces resilient and sustainable. It can be scaled from a single unit to a neighborhood, to a city, or a bioregion. And most important of all, it involves a deep engagement with the users who are the main stakeholders, and of course, the immediate ecosystem. So we had the International Earth Day yesterday, and I would like to begin my talk with this about how our environment is, having some serious challenges such as climate change. This picture here shows you the carbon footprint, the global carbon footprint, and India, being a developing country, has an increasing carbon footprint, and we need to think of how we can reduce these greenhouse gas emissions and make reduce our impact on the environment. If you look at the world carbon dioxide emissions, we are fourth, so we are somewhere contributing in a big way. And if you see the recently released World Meteorological Organization's report on uh, the impact of climate change and the status of the world countries, you'll see that there are huge impacts. For example, our global carbon dioxide emissions have hit a record high of 407 parts per million in 2018. The ocean heat has recorded the highest levels. And because of this, there's melting of ice, there's a whole change in our global ecosystem. Almost 26% of the seawater is today acidic as compared to pre-industrial times. And one of the main impacts that we are going to face is more erratic rainfall and weather patterns, and a whole lot of other things such as threat to our food systems, and a whole lot of other challenges such as floodings that we will have to be prepared in the future. And architects do have a big role to play in this. So let's look at the building sector and its contribution to this whole mess that we have created in the last few hundred years. We are one of the biggest contributor, single largest contributor to climate change. 30 to 40% of the total global greenhouse gas emissions are because of buildings, in addition to 1/3 of the global energy use. We use 40 to 50% of the total flow. Almost 3 billion tons of raw materials are being used. We generate 25 to 40% of solid waste, and 12% of global water use are used in buildings, which of course does not account for the whole lot of other uh, water use in materials. So the built environment has a impact which is one of the largest. It's next only to agriculture in the impact it has had on the Earth's ecosystems. We have changed the face of the Earth in many, many ways. So let's look at ecospaces, what it is, and what are the three cornerstones of this concept. The three cornerstones, one of them is resource optimization using minimal resources. We are focusing here on water, energy, and making everything net zero. Circular economy, this principle of making everything from linear to circular, to just as it is in nature, which involves building materials, our food system, and waste. And lastly, improving our environment quality, whether it is the outdoor air and noise or the indoor environment and the visual and the thermal comfort. All of these three are related, and they have a deep connection with sustainability, with making things resilient, and stakeholder engagement. Let's go to the resource optimization, which is the first in our cornerstones of the triangle. And we will look at how we can go about doing energy and water efficiency. Here I would like to again start with two graphs, which is important for us to note as far as the Indian scenario is concerned. We see that we still in 2018 use 56% of coal and 30% of oil. So we are still heavily dependent on fossil fuel energy, and we still are way away from reducing that consumption and increasing our renewable. And the second graph, you can see that buildings are consuming almost 30% of this energy. So both these two graphs show us where we need to go. We need to be more energy efficient, reduce the fossil fuel, and then move towards renewable energy. So our challenge is plugging the fossil fuel emissions. So how can we go about doing this? If you bifurcate or trifurcate the problem, it exists in three ways. One is designing energy efficient envelope. The second is energy efficient equipment. And the third is going towards renewable energy. This goes into a sequential way. For example, first reduce the energy efficient, make it energy efficient envelope. So then you reduce your cooling loads, reduce your lighting loads, reduce your energy efficient, and then you have the minimal thing that is left can be done with renewable energy. If you look at building envelope, we haven't gone very far in India. We're still using, for the external partition walls, we're still using fire clay bricks, concrete blocks, hollow concrete blocks. And it's very recent that we have come up with something as efficient as the AAC blocks, or autoclaved or aerated concrete blocks, which are far more energy efficient. The challenge is in terms of the external building envelope, how to reduce the thermal transmittance of the wall. So if you look at existing ones, where do we stand? A typical 230 mm brick wall, its U value is 1.5. And if our target is something like zero point 0.4, we are way away from it, almost 3 times as much. So we have a long way to go. If we reach zero point 0.4, then we are almost reducing the building's energy consumption to a big extent, 15 to 20% more efficient than the building. And of course, that has a cumulative impact on the air conditioning load as well. So these are the given standards. We have the Energy Conservation Building Code, which we can see that we have standards for warm and humid climate, for example, of zero point 0.4, and the existing walling material that we use do not reach this at all. So we have to be very careful about what we use on the external envelope. Similar to that, we have roofs. You can see that for most of the building types, it is 0.33. Now, if it's not a high-rise building, the roof plays a very important role because it gets the maximum amount of solar radiation. And therefore, we need to design a good thermally efficient roofing. This is very important. And to get that 0.3, once you get to that 0.3, you can be sure that you have reached that level. So there are various ways. Of course, using a good material and a good insulation is the first step. But there are various other ways that in which it can also be achieved, such as using extensive green roofs, shading for your roof. You can use a grass lawn on the top of your roof. You can have reflective China mosaic tiles, or you can have high albedo paints, or of course the radiant barrier insulation, which is the cheapest option among all these things. So there are various options, but it's important to know that we need to do this. Now, that was about the envelope. Coming to the consumption, we see that if we take a typical college building, this is how the loading, the electrical loading looks like. We have 30% on lights, 15% on fans, AC is 26%, and equipment is 29%. Now, there is a huge scope in all this to reduce the energy consumption. For example, what kind of lights can we make? Can we use more efficient lights, less lights, because there are so many lights in many places which are not being used, and then, or they are just used and just put on and so on. There are fans. We have today the brushless DC fans, which consume half of what the typical conventional fans. And then we have the 5-star air conditionings, which can reduce to a great extent the energy consumption. Just to give you an example, here is what a graph of a residential house looks like, where we have taken the energy performance index at the beginning of all changes, and then we have introduced the various instruments, energy efficient equipment, 3-star, 5-star, and so on. And we can see that the energy performance index has come down to almost half of what it used to be over a period of just 4 years. And this, mind you, that we have not used here solar thermal or solar heating panels on the roof. If that is done, this is going to come down to almost 15, 20, maybe, watts, kilowatt hour per square meter per year, which is very close to the German standards of passive house. So all this is achievable. So if you have your equipment load reduced, if you have your envelope very efficient, then you are having a very good house which is using optimal resources. And of course, the last step, which is the making the building net zero or nearly zero. The Bureau of Energy Efficiency of the Government of India defines a nearly zero energy building as one which uses less than 15 kilowatt hour per meter square per year. This is a very high target. And this is similar to the passive house target. But if this can be achieved, we will be way ahead in our reducing our carbon emissions. And can this be done? Yes, we have the example of our own Paryavaran Bhavan in New Delhi, India, which is India's first net zero energy building. which by simply making a building which uses a tremendous amount of natural light, optimizes the natural light. It's a multi-storied building, and the entire roof has been used for putting up solar panels, and it also provides shading to the building. And not only is it a net zero energy building, it's a net positive building. So I don't think if a government building can be done, I'm sure all buildings can be done. It's a challenge, but I'm sure it is possible. The next part of a resource optimization, which I would like to address, is water efficiency. Uh, the first step to water efficiency is making use of water efficient equipment, flow restrictors, pressure reducing walls, low flow rate systems, dual flush, installing water meters, sensor-based apps. All of these can make your water consumption lower. Of course, a very important aspect in this is how you maintain and monitor the performance of these. It's just not that when you make it, it will give you all the performance. You have to make sure it does perform. The second thing that can be done is rainwater harvesting. Whatever your site is becomes the catchment, the amount of rainfall falling in your area, the average annual rainfall. This becomes the source, and the volume can be calculated. And this can be either stored somewhere, or it can be put into the ground, because we are not putting enough water into the ground. Our groundwater reserves are drying, and it's very important that we do this as just to revive our aquifers. It is possible to do rainwater harvesting. We have done it in numerous housing societies and different institutions. Uh, and people have done it because they actually needed it. The first case here in Dombivli, they had a severe shortage of water. Relying on tankers was an issue, and therefore making your own water available was a boon for them. In another case, for example, there was water which was helped them in preparing, using for the extra activities such as cleaning and so on. And in another one, it was just providing or recharging the existing bore well, which was done. So rainwater harvesting can be done at individual ways. It can also be done at a community level. And here I'm sharing with you an example to show, because rainwater harvesting, designing a strategy for rainwater harvesting in high-rise building can be challenging, because you may not find the exact geological strata for recharging. You may have flooding issues. You may not have enough storage space. So here we combined various aspects such as continuous percolation pits, baffle walls, recharge pits, and so on. And we were able to provide a rainwater harvesting system of almost 3.5 lakh liters of storage, and about 70% of peak runoff. We saw that this load of 100 per hour was taken care of. So there are challenges in designing, but it is possible to do so. And the third strategy, as far as water efficiency is concerned, is recycling the water. The easiest thing to do is to recycle gray water. You can use a reed bed system. And the reason I've shown you all these examples, courtesy Eureka Forbes Institute of Environment and Natural Solutions, is it is possible to use reed bed systems, which are natural way of treating your water and recycling it and using it for various other purposes. There are numerous examples of this. And of course, the National Energy Environmental Research Institute has also come up with a phytorate treatment system very similar to this, which is a very efficient way of treating your gray water and your black water within your system. The second corner of our triangle is about circular economy, and this is a very popular term today. But basically, as far as buildings are concerned, it is a life cycle analysis approach. It applies to all building materials. It applies to buildings. So even if you take a simple building material such as concrete, it can be more efficiently, the resource optimization can take place by changing different aspects of it, such as use of different types of sand and so on. And basically seeing that through the life cycle, for example, in the manufacture of tiles, some part of it can go back into the system, and then you use much less raw materials, much less virgin materials. This is the whole idea of the circular economy, to make use of waste as a resource, to go back into the system. So life cycle assessment is a way of assessment which is a holistic yardstick for environmental performance, which looks at climate change, acidification, eutrophication, fossil fuel, um, ozone depletion. What are the various different steps in the manufacture of a building material which causes damage to the environment? So it's a very important tool for you to assess. And one of the things that is part of a circular economy and the life cycle analysis approach is the embodied energy of a material. How much is the embodied energy? We try and use materials which have low embodied energy. So, or materials which can be recycled and reused. Even if they are high embodied energy, we can have that aspect of recycle. Of course, recycling takes a little bit more energy as well. So the National Building Code 2016 came up with a whole chapter on approach to sustainability in buildings, and it provided various category of building materials, such as very high embodied energy, high to medium embodied energy, and so on, which can be used as a tool for us to understand what materials to use. In general, these are the various characteristics of sustainable building materials. We can see that it is important to use materials which last longer or which are durable. You can see outside the circle all these various points that are mentioned: low embodied energy, materials that can be recycled, materials which are rapidly renewable, such as bamboo, or materials which have minimum water consumption during their manufacture, and so on. So this is just a tool. There are more than about 50 different parameters for measuring sustainability of a building material, and there are various indices by which you can measure them as well. What are the different options so available for us? So there are different uh, principles behind these materials which have been chosen here. For example, you have bamboo, which is a rapidly renewable material. You have fly ash blocks, which are using waste as a resource. You have uh, the filler slabs, which use clay pots, reducing the resource consumption. You have precast, which reduces time of construction. You have use of organic materials such as bagasse, coir, wood substitutes, and so on. These are all different materials which are available for us to use as green building materials. Here I'm sharing with you an example of a building where we tried to predominantly use all the principles, such as we use bamboo walls. It was a artist house, we have artist house and studio. So you use bamboo walls, pillar slabs, local stone, rubber tires, reuse of old doors and windows, mud and cow dung flooring, and we tried to not disturb the landscape in the place. So there was a courtyard, the trees remained, and so on. Of course, Auroville is an example. In the south of India, we have Auroville, a small community of people who have done a lot of experiments in building materials which are sustainable, such as adobe walls, compressed stabilized earth blocks, ferro cement, wattle and daub structures, and various other things. Two examples that I would like to share as far as building materials. The first one, not in India, it's a San Francisco Bay Conservation Center. It uses straw bale, a material that is in abundance with almost all farmers. Use it as a wall. It provides a very balanced temperature throughout the year indoors. It's a natural material and it provides you excellent indoor air quality. The second example is a building in Mumbai wherein the entire building debris was crushed on site to generate new bricks and new material for the building on the site itself. So, no pollution involved, no topsoil removal, and so on. So, no virgin materials. So, following the principles of circular economy. Another thing that needs real attention in terms of circular economy is waste. We all know that waste is a huge issue around every mega city. We have huge dumping grounds. We have almost hectares and hectares of land which we use for dumping our waste simply because we are not segregating them at source. And there are so many negative impacts of this, such as the air pollution, the soil, groundwater, and the marine pollution that occurs, the odor. And of course, the worst of all is the bioaerosols, which go into our environment and can affect our health. So, decentralized waste management within the building system itself, depending upon the kind of waste, whether it is what kind of the characterization of the waste is very important, so we can decide whether it can be vermicomposting, organic composting, biogas, which can also include night soil if it's a small building, and where there is no space whatsoever, and not really recommending, but no space whatsoever, then electrical composting is also possible, which gives you in a very short period of time. um, then dealing with the recyclables, every building should have the facility for segregating and dealing with the e-waste, which we generate a huge amount, as well as all the other waste. Of course, in India, we do recycle a lot. The last of our three triangle is the improved environment quality. Most of our design is centered around making human beings comfortable, whether it is a psychological comfort, physical comfort, spatial comfort, acoustical comfort. So all these aspects are very important, and here I'm focusing on two things just at the point: thermal environment, maybe the visual environment, and also the acoustical. So as far as the thermal environment is concerned, of course, we can use mechanical energy and make yourself comfortable, but that's going to use a lot of energy. So here are some passive cooling techniques, simple ones: shading. Then you have the solar chimney used for decades. Historically, we have the wind scoop. We have geothermal cooling, which is using the Earth's temperature. We have drum wall. We have wind tower. And of late, we have the passive downdraft evaporative cooling systems, which uses water for cooling, and also the thermo drain system, which is an entire system, which, for example, uses water as a means of cooling and providing thermal comfort inside buildings. So I'll share with you two examples of what was done in buildings. The first one is a college building in Mumbai where we had done a retrofit for achieving thermal comfort and energy efficiency. The building was highly uncomfortable on the topmost floor. So, among the various things that were introduced to make the building more comfortable was the dry walls, the use of high albedo paints, the use radiant barrier material, which, as you know, the thermal transmittance is very low. It's a very low emissivity material. And we have turbo ventilators, which induces stack effect. We had polycarbonate sheets, which allowed more light. We had removed the walls, and above the walls, we provided sheets which allowed light, and we added more skylights. And of course, in terms of spatial retrofit, we added cross ventilation by increasing the windows, by removing a false ceiling and allowing for stack ventilation, and making more windows and increasing cross ventilation. So a typical building where you have false ceiling, partitions which stop the flow of air, and we allowed for the flow of air, allowed for convectional movement in a non-air conditioned building, and it showed us results. So this shows that the use of radiant barrier, how from 4.64 watts per meter square Kelvin, we reduced the thermal transmittance to 0.03. These are some pictures before and after. So you can see the volume has been increased, and the radiant barrier material, which does not allow heat to come inside the building. And the results showed us that on an average, with the same temperature and the relative humidity compared, we had a average roof bottom temperature which had more than 10 degrees, almost 13 degrees difference. So that means a better indoor environment because the overall mean radiant temperature of the building is reduced. This is the second example of a passive cooling system where a building in Nashik, which uses a thermo drain system using water, which is stored in an underground tank to cool the building. These are pictures of when the construction was going on and after completion. And the results were excellent. This building does not use any energy for any air conditioning system for cooling. And what we found is this TOD system is energy consumption is less than 10 times. The capital cost is almost half, and the energy cost, which is a recurring cost, is almost 8.7% of the conventional system, and the overall life cycle cost is 1/5. A similar low energy passive cooling system is the down draught evaporative cooling system, which was used in the IGP complex in Gulbarga very successfully. Among the other aspects indoors is the air and noise pollution, which are, our cities have all these issues of air and noise, and whatever is outdoor eventually comes indoors. But what is important is that indoor is far more polluted than outdoor, because we spend a lot of time indoors, and the contaminants tend to concentrate in an enclosed space. So our idea of generally what is responsible for a good health is either eating the right food, having the right lifestyle, or staying in the right environment. But no, it's also important that you have a good indoor environment, or rather a poor indoor environment can lead to a sick building. So these are the various contaminants, the physical, biological, and chemical. The biological ones are the most dangerous. The chemical ones are important because they can have long-term impacts, and the physical ones are also very important. So in a typical building, typical office, you have these various pollutants, VOCs, the volatile organic compounds, dust, biological contaminants, and so on. But overall, if you want to make your building healthy, you have to see that it is non-contaminated or not a brownfield site. If it is a brownfield, it has to be treated. You have to have universal access to all people. You have to see that it's earthquake and fire resistance, it's climatically sensitive, energy efficient, and it is well insulated in terms of sound. That means it eliminates all the bad sound. And here I want to give an example of a house in Kem's Corner, Mumbai, which uses traditional practices for improving the indoor environment. So you have they use cow dung flooring, lime plaster, copper, timber, no use of chemicals at all. So the indoor environment of this house is something to experience. The use of plants indoors has proven that research has proven that not only are they capable of purifying the chemicals in the environment, but also help in lowering, of course, in adequate quantities if they are present, that they can lower the temperature and provide you a better indoor environment. I'll discuss with you a few standards and benchmarks which are very important with reference to all that I have spoken so far. First is the National Building Code 2016, which has a new chapter, Chapter 11, on approach to sustainability, which provides you all of these new points, which gives you idea on how to design sustainable buildings. And the Energy Conservation Building Codes, which was launched in 2007, has a newer version released in 2017. These were for commercial buildings. And now we also have the Eco Nivas Samhita for the residential buildings. So many of the states in India have already mandated the use of these codes. Then we have the voluntary star rating system to measure your energy performance index. And you can get a labeling for that. This is for commercial buildings. Similarly, it has also been started now for residential buildings. So you can put a plaque outside your house if your house is energy efficient. And that's also sends a message to others to make their house energy efficient. Lastly, a few models that I want to share. Um, the first one is the Empire State Building in New York, a building that was built in 1930s, a massive building, but it had a huge energy consumption. But it has managed to reduce its energy consumption by almost 40% by retrofit. Retrofit includes windows. Almost 6,500 windows were changed from single glazed to triple glazed. The change in the chiller systems and many other things which have made a huge change in the energy consumption of this building, and this can be done in all the cases. A far more newer example is the Tel Aviv University's Potter School, or what is prominently or popularly called as the Capsule Building, which uses a very innovative system of solar vacuum pipes on the facade of the building to cool the building. So again, no conventional air conditioning. And then, of course, it has various other things. It is treating of the wastewater right there in the compound itself. It has a cool roof with all kinds of plants on the roof, and it uses recycled furniture and so on. A lot of interesting things here. And when we talk about sustainability, it's not just about buildings, it's about cities, because here is the battlefront where most of the wars are going to be fought, especially related to climate change. So we have the example of cities like Masdar, designed by Norman Foster, and one of the first cities which is supposed to be net zero energy, which means it relies entirely on its own for its energies, doesn't go outside. So there's a huge solar plant in the desert installed, which runs the entire city. And why just cities? We also have sustainable communities. We need to have sustainable villages and neighborhoods. So Freiburg in Germany is a good example. Auroville in India, Findhorn in UK, Crystal Waters in Finland, and Gaia in Denmark. These are excellent examples of communities which have not only become self-sustainable, which are growing their own food, which even have their own money in some cases. So moving towards the whole idea of sustainability and resilience. And why go very far? If we want to look at the physical characteristics, we have our own cities, beautiful cities of the past. We have a huge cultural heritage to learn from and to replicate for the future. And the 2 points that I would like to just expand before I close my talk, and this is related to resilience of buildings and cities. Resilience relates to how we prepare ourselves for the future. And when we talk about future, one of the biggest challenges is climate change. So already there are cities which are planning to prepare themselves for adaptation to climate change. So Ho Chi Minh City, Tokyo, London, and many other cities around the world have prepared plans for the future about how to make buildings. Some of them are making buildings which are floating in the water. So what kind of preparation do we have for the future? Resilience. And The last thing is about stakeholder engagement. And here I would like to give an example of a project on village tourism, which we did with a group of master students in Sindhudur district in Maharashtra. 21 villages and 5 circuits. We did a master plan for sustainable village tourism. The entire focus of this project was stakeholder engagement, beginning with the students themselves who designed the design brief, who prepared the design brief, and they engaged with the community to see what their needs were, to verify their needs, and a lot of data collection was done to see that the proposals were based on a very sound footings. And so the entire process, right from the government to the district government to the state government to every level of government to people, all the stakeholders were engaged. So this is what I mean by deep stakeholder engagement. The process is really important, that we engage in this kind of process. The second thing that second project that I would like to share is a much smaller project where we designed a school and Anganwadi toilet, designed with the Israeli industrial designer Tamara Kov. We took care of all the Ecospace components, but more importantly, we engaged with the students of who actually helped us in letting us know what their needs were, what their thoughts were, and how to go about the design. So I end with these very important words by our stalwart H. Kumar Vyas, who said, design in the final analysis is an agent of change to enhance and improve our material, psychological, and socio-cultural environments while maintaining harmony with the ecology of our planet. Thank you.